video, I'm going to go over how to calculate the average atomic mass. So this is for an element where there could be multiple isotopes. So it says here, the average, meaning it's important to take into account the different isotopes of the element and their natural abundance, so how frequent they are in the Earth. If we do some examples, the relative abundance of two isotopes of chlorine, so Cl on the periodic table, with atomic masses 35 and 37, are 75% and 25% respectively. Calculate the average atomic mass. So, as you said, per the definition, we take into account the atomic masses of the isotopes and their abundance. So, to calculate it, because it's 75% of 35, so it's 35 multiplied by 75 plus 37 multiplied by 25, all divided by 100. So, in other words, this sentence basically means 75% of chlorine on the Earth is atomic mass 35, and 25% of chlorine on Earth is atomic mass 37. So to calculate the average, we take into account their abundances and we add the abundances together. Thankfully, it adds to 100. So if we equal 35 multiplied by 75 plus 37 multiplied by 25 divided by 100, we get 35.5. And if you look on the periodic table, the atomic mass of chlorine is 35.5 to 1 decimal place, because it takes into account these abundances. If we do another example, the relative abundance of two copper isotopes are 69.15% and 30.85%. The atomic masses are 63 and 65 respectively. So same again as chlorine, but this time with copper. So 69.15% of all the copper on the Earth has atomic mass of 63, and 30.85% of all the copper on the Earth has atomic mass 65. So we take into account the atomic mass and their abundance. And then divided by the total abundance, which is 100. Usually if you're given percentages, the total is 100, because percent means out of 100. So 63 multiplied by 69.15 plus 65 multiplied by 30.85 divided by 100. The atomic mass is 63.617. On the periodic table it may be rounded to 63.6 to 1 decimal place. So that's the relative atomic mass of copper. We have a last example. So calculate the average atomic mass of potassium. So potassium is K on the periodic table. So we have these atomic masses and we have these abundances. So this time the abundance isn't given as a percentage, so we'd have to calculate the total abundance. So we take into account the atomic mass multiplied by the abundance. So 0.93 plus 40 multiplied by 0.00012 plus 41 multiplied by 0.067. Divide all that. If we sum the abundances, it's 0.99712. If we put this entire thing in the calculator, we get an average atomic mass for potassium of 39.135. 1 decimal place would be 39.1. So that's how you calculate the average atomic mass of an element with its isotopes.